So this is the sample exercise 1011 from page 412. All right, a study of the effects of certain gases on plant growth requires a synthetic atmosphere composed of 1.5 mole percent CO2 and 18 mole percent O2 and 80.5 mole percent of argon. Okay. Part A, calculate the partial pressure of O2 in the mixture if the total pressure of the atmosphere is to be 745 torrs. Okay, so the first thing that it helps to understand is that mole, okay, so mole percent is the mole fraction after you turn it to a decimal. So, for example, so we're doing the partial pressure of O2, right? So the 18, the 18%, 18.0 mole percent of the O2 is 0.180 as the mole fraction. Everybody okay with that? All right. So we're using the mole fraction equation or concept. So the pressure of, we want the partial pressure of O2. Pressure of O2 equals the mole fraction. So you could either do this as like the n like this, n sub O2 over n sub nt, or you could just do it as x sub O2, that's the mole fraction of O2, times the pressure total. Okay? So all you have to do for this one really is the pressure of O2 equals the mole fraction for O2, which is this, 0.180 times the total pressure, 745 torrs. So the pressure of O2 equals 135 or 134, sorry, torrs. Okay. Yeah.
You don't need to change it in atmospheres?
Not unless they specifically ask for it.
Oh, okay.
If they specifically ask for it in something, then you can, but here you don't need to. So one thing that you might want to jot down, I'll put it in a different color on here so you can see it a little more easily, but basically the mole percent, can you see that? Yeah. The mole percent divided by 100 equals the mole fraction. And then you can do it the other way around as well. The mole fraction times 100 will give you the mole percent if they ever ask for the mole percent. Okay. Any other questions about the first part? All right, let's take a look at part B. If this atmosphere is to be held in a 121 liter space at 295 K, how many moles of O2 are needed? So we've got a volume of 121 liters. We've got a temperature of 295 Kelvin. We're looking for N of O2. So that's moles of O2, right? So this is the information we have. Okay. And it was talking about this atmosphere from above. So we know that the pressure of O2, we found that out, is 134 torrs. Okay. We got that from up here. So all we need is, we're looking for the N. So we're just going to run Pivnert, solving for the N. So it's going to be PV over RT, right? So our pressure, now if we look, we've got torrs and we've got liters for volume, right? So anybody have the R factor thing in front of them? Isn't the one like, is it 62.36? And that's liters and torrs on the top for the label? Okay, we're going to use that one then for the R factor. So that means we don't have to convert any of our labels in here. So our pressure, 134 torrs. Our volume, 121 liters. Our R is the 62.36 liters times torrs over moles K. And then our temperature is 295 K. All right, we do the math, and it comes out to be 0.881 moles of O2 is our answer. So that one's kind of really just kind of a straightforward Pivnert, but you just got to kind of watch and like know what you're talking about in terms of your labels and stuff. Any questions on that one?